Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nur Aziza binti Sukardi. I am from Group 4 and I will be presenting the manual calculation for question 4. So, this is the circuit given in the question. And then, for question A, given that IST is equal to 3 UT and we need to find the VFT and IT for T is greater than 0 in the circuit. Our group are using Laplace transform method to solve this problem. So for the first step is we need to convert the circuit into S domain, and then we get the circuit looks like this. Next step is to find the IT by finding the IS first using voltage divider rule, which is 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 equal to 5 times 3 over S plus 20 over S divided by 5 plus 5S plus 1 plus 5 over S plus 2, which we get the IS is equal to 7 over S squared plus 8 over 5S plus 1, and then we convert this form into this form by finding the value of A and omega using this formula, S squared plus 2AS plus S squared plus omega squared, which we get the value of A is 4 over 5 and the value of omega is 3 over 5, and then we get IS is equal to 35 over 3 times 3 over 5 over S plus 4 over 5 square plus 3 over 5 square. And then by applying inverse Laplace transform to the IS, we get IT is equal to 35 over 3 exponent negative 4 over 5t sine 3 over 5t ut. Next, we need to find the VFT. But first, we need to find VS, which is VS is equal to 5 over S times IS. IS we can get from here. So we get VS is equal to 5 over S times 7 over S squared plus 8 over 5S plus 1, which is 35 over S multiplied by S squared plus 8 over 5S plus 1. And then we need to convert this form into partial fraction form, which is A over S plus BS plus C over S squared plus 8 over 5S plus 1, and then we need to find the value of A, B, and C by solving the partial fraction. Then we get A is equal to 35, B is equal to negative 35, and C is equal to negative 56. Then we get Vs is equal to 35 over S plus negative 35S minus 56 over S squared plus 8 over 5S plus 1. And then we need to convert this equation into the form of S plus S squared plus omega squared, which is S plus 4 over 5 squared plus 3 over 5 squared. And then from Vs here, we apply the inverse Laplace, that is using this formula in the box to find VFT, which is 35 minus exponent negative 0.8t times by 35 cos 0.6t plus 140 over 3 sine 0.6t ut. Next, we need to substitute the value of t in order to compare the result in the simulation. Our group used the value of t is equal to 10, and then we get VF10 is equal to 34.99 volt and IT is equal to 4.09 times 10 to the power of negative 4 ampere. So for the question B, given that IST is equal to 30 UT and we need to find VFT and IT for T is greater than 0 in the circuit. Same as question A, first we need to convert the circuit into S domain, and then we get the circuit in S domain like this. Next, to find IT, by finding the IS first, using voltage divider rule, which IS we get 34 over S square plus 8 over 5S plus 1, which we will transform this form into this form. And then we get the IS is equal to 170 over 3 times 3 over 5 over S plus 4 over 5 square plus 3 over 5 square. And then by applying this formula, we can get IT, which is 170 over 3 exponent negative 4 over 5t sine 3 over 5 t ut. Next, to find Vt, we need to find Vs first. Vs is equal to 5s times Is, which is 34 over s square plus 8 over 5s plus 1, and then we get Vs is equal to 170 over s multiplied by s square plus 8 over 5 s plus 1. And then we convert this form into partial fraction form, which is a over s plus bs plus c over s square plus 8 over 5s plus 1. And then we solve the partial fraction to find the value of a, b, and c. That is, a is equal to 170, b is equal to negative 170, and c is equal to negative 272. And we get the Vs is equal to 170 over s plus negative 170s minus 272 over s square plus 8 over 5s plus 1. And then we convert the equation below to the form of s plus s square plus omega square, and then it will look like this. Next, we apply the inverse Laplace transform formula here to get the VFT. Then we get VFT is equal to 170 minus exponent negative 0.8t multiplied by 170 cos 3 over 5t plus 680 over 3 sin 3 over 5t ut. Next, to compare the value in the simulation with the manual calculation, we substitute the value of t with 10. That we get VF10 is equal to 169.94 volt and I10 is 1.987 times 10 to the power of negative 3 ampere. So for the last question, question C, is to compare the results between A and B. So in both results, the time constant is the same because it only depend on the circuit element. And then by substituting the value of T is equal to 10, we get that the magnitude of both voltage and current on the question for B is higher than the value of the current and voltage in question 4a, and this is because the value of current source in question 4b is higher than the question 4a. So that's all for the manual solution for question 4. Thank you.
Hello, Assalamualaikum and good morning, Doctor. My name is Muhammad Irfan bin Hot with matric number CE210186. For this project that we have been carried out for this semester, so for the task given to me is the simulation part. So for the simulation part, I'm using MATLAB instead of PSPice. It is because I get used to MATLAB before, so I know certain component and also I know how to get the input for this project. So let's we go for this project. So this is question for our group. We are from group 4. So the question we need to create the circuit to find out the VT and also the IT. So the data given is IS IST is equal to 3, and also second part is 30 for IST. So let's move to the simulation part. Okay, first we need to change the IS to 3. So this is 30, we need to change it to 3. Okay, this is 3. Next, we need to run the simulation to get the output. So this is the current measure for the current measurement, and also the voltage. Okay. Okay, we have some. Okay. Okay. This is for the voltage. So we need check for the graph. Okay. What we find out is graph for the voltage is increasing, and also at the some point they have some changes, and then they become constant here. Okay. Next is the current. Okay, for the current, we have increasing part, and at some point they have decreasing and also the constant part here. Okay, this is the measurement what we got from the manual calculation here. Okay, next for the second part, we need to change the IS to 30. So we need to put it 30 here. Okay, next we need to run it again. So basically we need to always run it if we have major or minor changes in the MATLAB to get the different output. So here we also get same value in the MATLAB and also manual. So this is the measurement, and then the output here, the graph. So also same. So the data given is increasing, and some changes here, and then it become constant here. So for the current, same here, increasing, and also become constant. So what I can summarize or conclude here, I have proved manual calculation and software is the same. So the theory of voltage divider rule has been applied during the manual calculation with combination of mathematical modeling knowledge. So second, for me, I have faced some difficult problem because some problem in the MATLAB, because I just know a little about the MATLAB. So just a little component I know, but this is something new for me to learn here. And then for circuit analysis using this platform, and after a few try and referring to multiple sources, so I have applied to the simulation and successfully made it for this project. So this is what the for this project need to do for our group. Okay, that's all for the simulation part. Thank you.
Assalamualaikum and hi, my name is Abdul Hasif. Now I'm going to talk about the discussion. The current divider rule and partial fraction are two methods that we use to accomplish the inverse Laplace calculation based on the computation above. We use the same method for problems for A and for B to calculate the value. In order to begin the calculation, we firstly convert the form into a frequency domain form because the question was in the time domain. As a result, we are able to obtain the value for IT, but in the S domain of Ohm's law. The partial fraction is used to extend the polynomial after replacing the value of IF with FVT. So, after we done extend the polynomial, after replacing the value of IF with VFT, then you can see that we get this equation. For question A, we will get VFS equals to A over S plus BS plus C over s squared plus 8 over 5s plus 1. And for question B, we will get VFS equals to a over s plus bs plus c over s squared plus 8 over 5s plus 1. That's all. Assalamualaikum. My name is Muhammad Farhan bin Muhammad Yusof. My metric number is CE210182. I'm from section 4, group 4. Now I will continue the discussion. Value for the question A, VFS is equal to 3 UTV and IT is equal to 4.09 times with 10 power of negative 4, while our simulation value is 34.99 volt and negative 0.001094 ampere. And an error was made when students attempted to solve the simulation. They were unable to obtain the same numbers as those from our manual calculation. To compare the result with student manual calculations, MATLAB simulation was implemented. The answer that the student received is not equal since there may have been a calculation error or some errors when utilizing the simulation.